Okay, so what we were talking about is, say I have a data set, okay, and that data set consists of certain attributes. Say for example, the first attribute is f1, and that has got set of values, say 10, then I have got 11, then I have got 12, okay, then I've got 14, and then I've got say 16, okay, and then I've got 19. Okay, so there are set of observations like this. Okay, now I have, and same way I have got f2 and I've got f3 and some predictors of this sort. Okay, we have like this, we have more such predictors, and we have got one particular target variable, say c. Okay, now what I mean to say is, first thing is, we need to understand, we need to find the mean, median, mode, or the measures of this dispersion like variance for a particular attribute. Okay, for each of the attributes we can either measure the central tendency or we can measure the dispersion, right? So for example, I want to look at the particular attribute f1. Okay, so f1, this is the set of values. So what we say is the xi for f1, the feature f1 are all these values. Okay, these are the xi's. Now what is my x bar? That is the mean. This is nothing but summation of xi, okay, summation of xi divided by n. Now what is summation of xi? If I just do a simple maths here, so 10 plus 12 is 22, then 22 plus here I have got 30, right? 11 plus 19, so that is 30. So basically 30 plus 22 is 52, and again 30, so 82. So here I've got 82 divided by, we have got n is 6, so total number of observations is 6. So this is my x bar, right? So I'm just using, say I'm just calculating the value of the dispersion. Okay, so I have got x bar here as 82 by 6. Let me take a rough estimate of the, I mean, let me just round it up to 7. Okay, so let's make this as 14, and this whole thing will come as 84 by 6. 84 by 6, no, not 7, I'm sorry, it's not going to be 7. So this is going to be 1 second, 18, right? 1 8. So 18, no, sorry, 14, I'm sorry, 14.
14.
And now what I will do is xi minus x bar, I will do the calculations. So 10 minus 14 is minus 4. Then I have 11 minus 14 minus 3. Then I have got 14 minus 14 is 0. I have got 14 minus 14 as 0. I've got 16 minus 14 as 2. And I've got 19 minus 14 as 5. Okay, then I do what? Then I do a xi minus x bar square. So I do a xi minus x bar square. Okay, so what does it come to? This comes to minus 4 square, which is 16. Okay, then I've got minus 3 square, which is 9. Then I've got 0, 0, then 4, and then 25. Okay, if I do a summation of this thing, 25 plus 25 is 50 plus 4. So my summation of xi minus x bar square is 54. Okay, this is my summation of xi minus x bar square. Now what I do is divide it by n. Again, I've divided by n. So 54 divided by 6 is coming as what? 9. This is my variance. So what is my standard deviation? My standard deviation is going to be root over of my variance. So root over of 9. So my standard deviation is going to be what? 3. Now, the context which I was talking about is, this is a measure of dispersion. So that means it tells me how dispersed the different observations are. Okay, so what I mean by dispersed, I mean how much spread out are the different observations. So now if I consider from the context of, say, the section A students and the section B students, I have got section B students which have got a mean value of, say, 65.2, and the section A students which have got a mean value of, say, 64. Okay, so I can say section B is better than section A because their mean value is higher than the mean value of section A. But then when I do the measure of dispersion and I calculate the standard deviation of the students, of the marks in discrete maths of the students, I find out that the section B students have a standard deviation value of, say, 5. Okay, and this is the section B students, and the standard deviation of the section A students, I have got a value, say, 1.1. That means the standard deviation of the students of section A is much lower than that of section B. Okay, now what does this mean to me? That means if you just think about it, I have got a bunch of students in section B who, in a overall perspective, they have scored more average marks. Okay, so that from that perspective, they can be considered as better students. But when I consider the standard deviation, I see that section A students, they have scored much uniform marks because their variance or their dispersion or their standard deviation is much lower. That means what? I have got a set of students in section A who are much less dissimilar from each other, who are much similar to each other. That means what? When I'm going to teach in section A, the way I can teach the students is much more uniform. I can give a much more uniform set of concepts to section A, whereas when I go to section B, I can see many students have scored very low marks and many students have scored much high marks. That means what? I have to think that there are students who have much lesser ability to understand the concepts, and there are students who have much better ability to understand the concepts. So when I uh, give the concepts, I have to give in a fashion which can address both the set of students. So I have a more heterogeneous population in the class. So that way, I can say probably when I go and teach the section A, it is much convenient for me to teach section A because section A has got a set of students who are much more similar to each other from a purely ability perspective, ability to understand the concepts, right? So that way, uh, when I do a measure of central tendency, I'm not getting a full picture about the composition of the students in terms of the ability of understanding the concepts of discrete maths. Whereas when I do measure the dispersion, I have got a much better perspective about the quality of students in section A and B, purely from the perspective of understanding the concepts of discrete maths. Okay, so this is how we can use the two different statistical measures, the measures of central tendency and the measures of dispersion, to understand how the different instances or the different students or the different observations in a particular uh, data set or in two different data sets are. We can compare the two different data sets in a much more holistic fashion. Okay. These are the two different measures of dispersion and central tendency that we talk about. Now talking about the third measure, okay, the third measure is the measure of what? how the data spread is. Okay, or the data position, the value of the data position. Sorry. So the first is central tendency, second is data spread, third is data value position. Now, this is another possibility that when we are measuring central tendency, right? What we can see is probably there are lot of students having very low marks and there are a lot of students having very high marks. So in such a case, what you will see is both the central tendency is high, sorry, the dispersion is high, but the central tendency is much low. But when we try to measure the data value position, there also we will see there is a lot of I mean the difference in the data value position. Say for example, if I just consider this as a number line, right, and we consider the marks of the students from 0 to 100, right? So the other way which can be look which with which we can look at the data is how the data is being distributed. So we might figure out that lot of concentration of data is coming in the first quarter. So if I look at if I distribute the data into four different portions, right? So the first portion is so if I divide the group into two portions, say for example, the data is arranged in a ascending or a descending order, and we divide the data into two segments. So the first segment and the second segment. And the middle position, as we know, is the median value, right? So what we can see in this case is how many observations have value less than the median and how many observations have value more than the median, right? So what we can do is we can see that more than the median we have, say out of 30 we have got say 10 observations. Okay, now these 10 observations we don't know where they are positions, and less than the median we can see there are some 20 observations. Okay, so this is what we can use the median and we can get an indication of the value spread. But if we want to do much more fine-grained analysis, what we can also do is instead of dividing it into two portions, we can divide it into four portions. Okay, and each of these portions we call it a quartile. So the first portion is the first quartile. Then the median comes, which is the second quartile or the Q2. Then we have the third quartile, which is the Q3. And then the maximum minimum value, which is the lowest value. Then we have got the first quartile, second quartile or the median, third quartile, and the maximum value, right? So this way we can look at the data distribution or the data spread in a much more fine-grained fashion, and for each of them we can see how many observations are there in each of these quartiles. That will give us an idea again how much spread the data is. Okay, but that understanding will be in a much more fine-grained fashion, because this case we are distributing the whole set of values into four compartments, and each of the compartments we are trying to figure out how many observations are there. Okay, so this is how we try to do a fine-grained analysis of the data spread. Okay, and we use the quartiles for doing that. Now, when we look at, I mean, I'm going to pause the session today here. When we look into the next session, we are going to see some graphical values corresponding to these statistical values, which are very commonly used in machine learning. So that is the first thing that we are going to do. Like one of the very important graphical plots that we are going to look at is the box plot, and a very important plot which uses the concept of quartiles and uses these quartiles to find out the plot of the data corresponding to the whole set of data. Okay, so value of each observation corresponding to the whole set of observations we are going to look at in the next session. So I'm going to pause